Hello students, these are the topic tests that Bodhee Prep brings for you. The basic idea of these topic tests is once you've done the basic concepts of a topic, you can take these tests to understand how well you're able to apply those topic or concepts in a timed test per se. Once you've taken the test, that is where this video comes in. In this video, we give you a perspective of what could have been a good attempt, which questions should have been attempted, and the solution for all the questions. And the best thing is there are more than 200 topic tests available on the Android app for Bodhee Prep. The link for the app is in the description below. So all you have to do is download the app and you can go through these 200 topic tests to fine tune your preparation and then make it better. This topic is about the HCF LCM topic, test number 3 as per the app. The analysis for this test overall will be, this test was an easy level of difficulty test. At least 7 odd questions you should get correct for a 95 odd percentile. And the attempt time will also be lower in the range of about 20 minutes because for the simple reason that most of the questions do not require forming cases and we are able to get answers directly. If we have a look at the questions, question number 1 says, the numbers 400, 536, 645 and divide by number n give remainders 22, 23, 24 respectively. Find the greatest such number n. So 400 minus 22, that is 378, should be divisible by n. 536 minus 23, which is 513, should be divisible by n. And 645 minus 24, which is 621, should be divisible by n. So basically we need the HCF of these three numbers and that will be n, the highest common divisor. If we look at the difference between these two numbers, the difference is 621 minus 513. 513. So this becomes 108. And the difference between these two numbers is 378 and 22 is 400, 22 and 113 is 513. So this becomes 135. This is nothing but 27 into 5. This is nothing but 27 into 4. So the HCF of the differences, that is 27, becomes the number. We'll just check with 27 whether 378 is divisible by 27 or not. 378 divided by 27, 1s are 27, 108, 4s are 108, and therefore the HCF comes out to 27, which becomes the answer. It's an overall easy question, just finding the HCF. 90 seconds should be good enough to answer the question. The numbers 2604, 1020, 4812, 4812. When divided by n, give the remainder 12. So the remainder is 12 in each case. Find the highest number n. Pretty similar to the previous question, 2604 minus 12. We can also directly take the difference, but again, I'll do the entire step. This becomes 2592, 1020 minus 12, which becomes 1008, 4812 minus 12, which becomes 4800. What we can do is we can probably, rather than taking the difference, factorize these numbers. So 4800 will be nothing but 48 into 100, which is 16 into 3 into 4 into 25. So this becomes 16 is 2, 4, 8, 16. 2 raised to power 4 into 2 raised to power 2, which is 2 raised to power 6 into 3 into 5 raised to power 2. 1008 will be 6 into 6 1 is 6, 4 0. 6 6 are 36, 4 8, 168. 168 into 4 will be 42. It should be 6 into 4 into 6, 6 into 7. 2 raised to power 2, 2 raised to power 1, 2 raised to power 2 raised to power 4 into 3 square into 7. And 2592 when factorized will be 1296, 648, 324, 47, 162, 81, which will be 3 raised to power 4. And therefore 1, 2, 3, 4, 5. 2 raised to power 5 into 3 raised to power 4. Clearly, the HCF will be the lowest power of 2, which is 2 raised to power 4. Lowest power of 3, which is into 3. So 5 is not present here, 7 is not present here. So 48. And therefore the value of n is 48. Again, basic question of finding HCF. Ideally, you should be able to do this within 1.5 to 2 minutes. And in terms of concept, it's an easy question. What is the smallest number which will divide by 9, 18, 24? Divisors are 9, 18, 24. Leave remainders 5, 14, and 20. If you look at the difference is 4 in each case. And therefore, when the difference is same, the smallest number is simply LCM of 9, 18, and 24 minus the difference. LCM of 9, 18, 24. 9 is 3 into 3, 18 is 9 into 2, 24 is 8 into 3. So 3 into 6 is already there, we need 4. So this becomes the LCM minus 4. This is nothing but 4 2s are 8, 3 is 72 minus 4, which is 68. And that is our answer because we just have to find the smallest number. Easy question, simple concept, calculation is not difficult, and therefore 90 seconds to solve. At a Sudoku hobby club, the words su, do, and ku on the display board are flashed using neon lights. When the display is switched on, the 3 words light up and remain lighted for 1 second. So, or rather on for one second, okay. After that, these words remain unlit for 2, 1 by 5, 5 to the 10, 11. 11 by 5 seconds, 17 by 4, and 23 by 4. Respectively. Each word follows its cyclic pattern of lighting up for 1 second and remaining unlit for its respective duration. What is the smallest interval? After which the entire display will glow together for 1 second. Okay. Now the light switches on, then is off. Will switch on and off. So this entire cycle, that is from starting off on to going off, and then again coming on, will happen after every. For the word su, it will be 1 plus 11 by 5, which will be 16 by 5 seconds. This will be 4 plus 17, 1 plus 17 by 4, which is 21 by 4 seconds. And this will be 1 plus 23 by 4, which is 27 by 4 seconds. So after this time, the individual lights will glow or will come to on position. So when will this happen simultaneously? Just take the LCM. LCM of 16, 21, and 27 upon HCF of 5, 4, and 4. LCM of 16, 21, and 27 would be 16, 21, and 27. 16 is 16, 21 is 7 into 3, 27 is 9 into 3. HCF of 5, 4, 4 is 1. 16 sevens are 42. 42 into 3 is 126. 126 into 9. 9 6 is 54. 4 carry forward 5. 9 2 are 18. 3 2. And therefore this will happen after 1134 seconds. 126 into 9. Wait, this is 16, sorry. I've made a mistake, calculation error, sorry. 16 into 7 into 9. 16 into 7 will not be 42. It will be 112 into 3 into 9. 112 into 3 will be 336. So 336 into 9. 336 into 9 will be 9 6 are 54. 4 carry forward 5. 9 are 27. 2 carry forward 3 30. 3024. So this pattern will repeat after 3024 seconds. That becomes the answer. I'd say medium level of difficulty, moderate level of difficulty, for the simple reason that the numbers are not very comfortable. Though you would have done question like this earlier. Yeah, therefore moderate. Attempt time could go up to 2.5 minutes. A sequence of positive terms is given by x plus 3 upon 3, x plus 8 upon 4, x plus 15 upon 5, up to x plus 80 upon 10. What is the least value of x such that x is not equal to 1, for which HCF of numerator and denominator is equal to 1 for each term of the given sequence, a sequence of positive terms. Okay. Now, if we look at this, each term, the numerator constant is nothing but here 3 into 1, here it is 4 into 2, here it is 5 into 3, and so on. Looking at the pattern, this is denominator into denominator minus 2, denominator into denominator minus 2, and so on. Therefore, each term of the event of the series is x plus n into n minus 2 upon n, such that n lies between 3 and 10 included, or both the terms included. We need that the HCF of the numerator, that is x plus n into n minus 2, and n should be 1. Clearly, the HCF of n into n minus 2 and n will be n. So, if there is no common factor between x and n, that is the only case when the denominator will be 1. So what is the least value of x? If we cannot put the value of x as 1, that is given. If we put the value of 2, the HCF will not be 1 for even terms when n is even. Similarly, for 3, the first term will not be there. For 5, the next term will not be there. There is also a term in this series, x plus 7 into 5 upon 7. So 7 also cannot be x. So ideally, x, if we put as 11, 11 will not be common with any of the denominator, so that is possible. And prime numbers after 11 is possible. So those are the kind of numbers that we're looking at. But since it's asked for the least value, one value that we can still look at is x is equal to minus 1. If you put x is equal to minus 1, all the terms will still be positive, and there will be a difference between the denominator and the constant term of the numerator, and they will no longer have a common factor, and therefore the smallest value of x will actually be minus 1. Bit of hit and trial involved here, but I would say this is a difficult question because it is very easy to miss the negative term and actually start with 11. Very high probability that we might get this question wrong. Find the highest number less than 1800 that is divisible by each of the terms 2, 3. So let us first find the lowest number which is divisible by 2, 3, 4, 5, 6, and 7. That will be the LCM. LCM of 2, 3, 4, 5, 6, 7 will be 2 into 3. For 4, we need 2 into 2, 4. 5 is there. 3 into 6 is there, 7. This becomes 5 2s are 10. 3 2s are 6. 6 7s are 42. So 420. Now, the numbers will be multiples of 420. We need a number which is less than 1800. If we multiply 400 by 3, it is 1200. 400 multiplied by 4 is 1600. 400 multiplied by 5 is 1000. So it will cross 1800. So the largest possible value seems to be 420 into 4. We'll check 081680. 420 into 5 will be more than 1800, and therefore the highest number less than 1800, that is divisible by each of the numbers, is 1680. And that is my answer. Again, easy question, not more than 90 seconds to get this done with. For how many natural numbers less than 1000? How many natural numbers less than 1000? Leave a remainder 4 when divided by both 5 and 11. So the smallest number which is divisible by 5 and 11 is 55. The number which leaves a remainder 4 will be 59. To get further numbers, we have to add 55 to it. So basically, my required numbers will be 59, or rather, let us start with the smallest number. Because we're looking at the remainder of 4, we'll start with 4 plus LCM of 5 and 11 into n. Because it does not say that the number has to be more than 5 or 11. How many natural numbers less than 1000? We'll start from 0. So the series will look something like 4 plus 55n, where the smallest number will be 4 plus 55 into 0, which is 4. Next number will be 4 plus 55 into 1, which is 59, and so on. What will be the largest such number? We have to be less than 1000. 55 into 20 will cross 1100. 55 into 18 55 into 18 will be 55 into 18 is 55 into 2 into 9, 11990. So if we write 4 plus 55 into 18, this will be 994, which is less than 1000. Anything beyond this will cross 1000. The multiplier for 55 goes from 0 to 18. From 0 to 18 are 19 values. 18 minus 0 plus 1, and therefore there are 19 natural numbers less than 1000, which will leave a remainder of 4 when divided by 5 and 11. And therefore, again, that's an easy sort of a question. The only thing is 0 we might miss out n is equal to 0. So I am saying moderate, but solving time definitely not more than 2 minutes. If the product of two numbers is 4 times their LCM. Now we know that, say if the numbers are A and B, product of two numbers is nothing but HCF into LCM. According to the question, product of two numbers is 4 times their LCM. That means the HCF of the two numbers is 4, comparing the two equations. Which of the following can be the two numbers? Because there are multiple solutions possible and it is asking a solution from the options, we look at numbers which have a HCF of 4. 62 is not divisible by 4. 81 is not divisible by 4. 50 is not divisible by 4. And therefore option D becomes the answer, because 24 is 4 into 6. 52 is 4 into 13. The product of the two numbers, that is 24 into 52, is equal to 4 times their LCM. What will be the LCM of these numbers? 4 into 16 into 13. As you can see, 24, 52, this is true. Hence option D becomes the answer. Easy question. The only thing is you have to spot the fact that 4 is the HCF. From there, you're just looking at options. But if it takes a bit of time to even spot that out, even then 2 minutes are sufficient to answer this question. How many natural numbers divide 2500, 42, 50, 6700 natural numbers, leaving the same remainder in each case? So to find the numbers that leave the same remainder, what we do is we take the difference of the difference of two numbers one at a time. That is a pair of numbers out of these three. So we take the difference of 42, 50 minus 2500. This will come out to 1750. And then we take the difference of say 6700 and 2500 will be 42, 40, or say 4250. This will be 1450, 1350, 650, 700, 1450. 2450, sorry. So the HCF of these two differences and factors thereof, they will be the numbers which will leave the same remainder while dividing these numbers. What is the HCF of 1750 and 2450? 1750, if we divide by 50, we will get 53s are 150 and then 35. 54s are 200 and then 49. This can be written as 50 into 7 into 5. This can be written as 50 into 7 into 7, which is 350 into 5, 350 into 7. Therefore, the HCF of these two numbers is 350. Hence, 350 and all factors of 350 will give me the same answer. How many factors does 350 have? 350 is nothing but 35 into 10. 35 into 10, which is nothing but 7 into 5 into 2 into 5, which is 2 into 5 square into 7. The number of factors of 35 will be 1 plus 1, 2 into 2 plus 1, 3 into 1 plus 1, 2. 12 factors are there. All of these factors, when they divide these numbers, will leave the same remainder, including one which will divide everything and the remainder will be 0. Hence, the answer is 12. Moderate level of difficulty, two different concepts involved. And therefore, I am saying moderate, 2.5 minutes, good enough to answer the question. How many numbers are there between 0 and 100? On which on dividing by 2468, leave remainder 1357. Divisor, remainder. As you can see, difference is is same in each case, which is 1, not 2. Sorry. The difference is same in each case, 1, 1, 1, and 1. And therefore, the smallest number which satisfies this condition is LCM of 2468 minus 1. How many numbers are there between 0 and 100? Okay. So this will be 2468. 2 into 2 into 3 into 2. 2 2s are 4, 3 2s are 6, 4 2s are 3, 2 2 2 2 is 8. So this is 24. So the smallest number which satisfies this condition will be 24 minus 1, which is 23. The next number will be when we add 24 to it, so 47, adding 24. The next number will be when we add 24 to it, so 67 and 4, 71, and then the next number will be 95. These are the four numbers between 0 and 100, so answer becomes 4. I think this is an easy question, especially because of the range. Not more than 2 minutes to answer this question. So if we look at the overall level of difficulty of this test, as I said, easy test, maybe one or questions are a little difficult. The rest could have been attempted easily or were patterns which you would have seen earlier. Attempt time also somewhere around 20 minutes should be good enough. The questions that I would choose from, if I had to choose 7 questions, would be 1, 2, 3, 6, 7, 9, and 10. Which are these ones? Would have done this direct common remainder HCF. Sorry, difference HCF application. Common difference HCF application would have done this as well. This is also basic application of the remainders. LCM would have done this. This question could have been taken a column, not the easiest of the 7 questions that I'm looking at. Similarly, this question, there is a high chance you'll get it wrong because the first instinct is to mark the answer as 11. So could have been left. This again is a repeat question, can be done. 7. So this also was not a very difficult question, though the initial 4 can be missed out. This I think was a better question. Again, if we start solving this, then it becomes a problem. But once you realize that HCF is 4, then it becomes a lot easier. Maybe looked at, can also be left in the sense that not a question which is repeated. So I'm not saying the easiest of the 7, of the one of the 7 easiest questions. This would be easy. Counting remainders. This again is a repeat question, should not be easy, especially because the range is also very less. Again, you can substitute 8 and 9. One might say 8 is easier, one might say 9 is easier. So that substitution can happen. But 1, 2, 3, 6, 7, 8/9, and then definitely 10 would be my pick.